Hello, in this video we will just take a quick overview of my project. First we are moving to part A, which is about human guided neural network design. The main goal of this part is to build and train a neural network from scratch to classify images from the famous CIFAR-10 dataset. Let's see how we did it. First, we need to set up our environment. As you can see, we are importing several important libraries. We have torch.nn for creating our neural network. Then we use Torch Vision to access and work with the CIFAR-10 dataset. And finally, libraries like Matploit and Seaborn are for visualizing our data. Next, we prepare our data. The CIFAR-10 dataset has 10 different classes of images like airplanes, cars, and birds. Here we download the dataset and apply some transformations. The transform to tensor part converts our images into a format that the model can understand. The transforms.normalize step helps to standardize the data, which makes the training process more stable. Next, we are going to the analysis part. Before training our model, it's always a good idea to understand our data better. So we did some exploratory data analysis. This bar chart shows the class distribution of our training data. As you can see, the dataset is very well balanced with an equal number of images for each of the 10 classes. This is great because it means our model won't be biased towards any specific class during the training. So these are the sample images. So next we are moving to the main part of our project. So this is the core of our project. Designing the neural network. We have created a simple convolutional neural network or CNN. It has several layers. We start with convolutional layers, which are like small filters that find features in the images like edges and shapes. Then we use activation functions like ReLU to make the new network nonlinear. The pooling layers help to reduce the size of the data and make the network more efficient. Finally, the fully connected layers at the end will use these features to classify the images into one of the 10 categories. So once the model is defined, we train it. This is the training part. We use a loss function to measure how wrong our model's predictions are. So we also use an optimizer to update the model's weight to minimize this loss. Well, in this training loop, we go through the data multiple times, the invert, which we call epochs. In each epoch, the model learns from the data, adjusts its parameters, and slowly gets better at classifying the images. So after training, this is the evaluation part. We evaluate our model's performance. The confusion matrix you see here shows us how many images were correctly classified for each class and how many were misclassified. For example, it tells us how many airplanes were correctly identified as airplanes and how many were mistaken for other objects. The classification report gives us a more detailed breakdown of the precision, recall, and F1 score of each class. So that's a quick overview for part A of my project. We have successfully designed and trained a neural network using a human-guided approach. Next, we are moving to the part B, that's a Gen AI assisted neural network design. So here we use a Gen AI tool to help us design a new improved model for our CIFAR-10 dataset. This AI assistant model is included advanced layers like batch normalization and dropout. Here's the result. The new model achieved a higher accuracy of approximately 74% compared to the 65% accuracy of the human-guided model that we showed at the first. So this shows how combining human effort with AI can lead to a more effective and stable model. Because as compared to our part A, the part B's results are very impressive and more accurate. The predictions are very higher than the other one. So this is the quick overview of my project. So thank you.